Okay, Mary Lou found the perimeter of this irregular polygon to be 19 units. What mistake has she made and what is the actual perimeter? You know, I'm going to go straight to finding the perimeter and then we'll see if we can figure out what she did incorrectly as we go. So I'm going to write what I know. And by the way, because you can't write in your textbook, that's fine. This sketch is actually not that hard to draw if you use a little bit of graph paper. And so I'm going to write what I know here. I know this dimension right here is 2. I know that this dimension right here is 1. This dimension here is 3. And all of the others, this one's 1 right here. So that's good. The others are going to be a little harder to find. So let's start with this one right here. I'm going to use, I want to know what this one is here, but I'm just going to think about the Pythagorean theorem and treat this as a hypotenuse. Do you see what I did there? So that means this leg right here is 3. This leg right here is 4. So guys, that's a 3, 4, 5 triangle. That means we don't even have to use the Pythagorean theorem. We know automatically that this leg, or this hypotenuse here is 5. Okay, moving on. All right, let's do the same thing with this thing. Let's build a little triangle right here, a right triangle. So this leg is 2, this leg is 1, right? So this is 2 and 1. Well, if you use the Pythagorean theorem on that, that gives you 4 plus 1. I squared 2, squared 1, that gives me 4 plus 1. That means this dimension is the square root of 5. Okay, so we have square root of 5 there. Actually, I should make that red, so these are all red here. So now this is square root of 5. All right, now let's go to this one. Okay, well, can you see that if we build a little triangle here, that's just going to be 1 squared plus 1 squared. That's the square root of 2. So this little guy right here is going to be square root of 2. That means that any diagonal for 1 unit is considered square root of 2. So look, people, this is going to be the square root of 2. See how this is one diagonal and this is another one? So this is 2 times the square root of 2. Cool, huh? Here's another one. Here's 2 times the square root of 2. All right? Oh, and look at this. Look at this. This is a diagonal that crosses over 2 squares. It looks a lot like this one, doesn't it? So this one is square root of 5. So we actually don't need to recalculate all of these for the ones that we've already calculated. Now we're ready to just add everything together. So I'm going to go through and find all the whole numbers, the ones that don't have any radicals in them. So here's 2, here's 5, here's 1, 3, and 1. I think I've got them all there. I can just add that all in my head. 5, 6, 7, 8, 9, 10, 11, 12, the way that looks, right? Okay, so there's 12. All right, now let's go through and find all the ones. Let's go through and find all the ones that have a radical 2 with them. Okay, so here's radical 2, here is radical 2, and here's radical 2. I think I got them all. So if we add all those like terms together, you see there's understood 1 here. So we have 1 plus 2, which is 3, plus 2, which is 5. So that's plus 5 times the square root of 2. Okay, now we just have, I think we're almost done, right? We just have this one here, and I'll change this to be yellow. I'll circle this in yellow again as well, so that we have square root of 5 here and square root of 5 here. So that's 2 times the square root of 5, right? Okay, and guys, that's it. 12 plus 2 times the square root of 5 plus 4. Ooh, I did something wrong. That shouldn't say 4 times the square root of 2, I don't think. 2 times the square root of 2. Oh, I know what I did wrong. Right here. This should just be 1 times the square root of 2. All right? So this becomes, this should just be 4 times the square root of 2. All right, so let me redo this. 12 plus 4 times the square root of 2 plus 2 times the square root of 5. Whew, that was close. Easy to make mistakes, isn't it? Okay? So I hope you stuck with me through the rest of the video and didn't write down the incorrect answer. Now, we do need to find the error in her calculation here. So I'm gonna suggest that probably what she did, let's see, let's make this real light yellow here, okay? Let's just go all the way around the shape here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I'm thinking that's where she got her 19. She just counted all the diagonals. She counted all the squares as one unit, even the diagonals. And diagonals, as we all know, are longer than just one unit.